I get the icon in cornflower blue?
Welcome to episode 37 of Can I Get That Software in Blue? I'm your host, Chad Tyndall. I'm joined today by our guest. You've seen him on stage giving a TED Talk, looking very perky. Most tech founders can be a little quirky, and he's no exception, having studied music composition at Berkeley. His journey is a symphony of innovation and creativity. This is actually our first episode recorded live here in San Francisco, here on Telegraph Hill, under the Tower of Coit. Welcome, CEO of Weaviate, Bob van Luijt.
Thank you so much for having me, Chad. I appreciate it.
It's nice to be here. It's nice to finally meet you in person. I've heard a lot about you.
Thank you.
Unfortunately, my co-host, Steve Mazak, this is our first episode where we're not doing it together. He had recently gone back to work at Elastic. That's where I met him. And he felt that since Weaviate and Elastic are kind of in competition with each other, maybe not directly, but a little bit, he just felt it wouldn't be appropriate and maybe a bad look. And so he wanted to recuse himself from this episode. So
I appreciate that. I think it depends a bit how you look at these kind of things, but there's just a company like Elastic is like, I look up to that, right? As in like when I started my career, I was using all these kind of technologies. So I'm kind of in this funny situation. On one hand, I of course understand that situation, but on the other hand, that also makes me very proud.
Right. You've kind of made it to the point where where you're seen as a competitor by this company that you look up to.
A friend of mine, he sent me a screenshot of like he wanted to look something up for Weaviate, so he typed it in, and he immediately sent me a screenshot. He said like, look. He said like Elastic is buying your keyword.
Wow.
So that was
keyword bidding on Weaviate.
Yeah, exactly.
Wow.
So that was very nice. So it was I seriously mean that. It's like these companies I just, I look up, to them. And it's like not only Elastic, but like also others in the space as well. And some are a little bit more competitive, others aren't. I hope that we can go a bit deeper during our conversation and why I think this is really something different that we're doing.
Yeah.
Of course, there's overlap. But I mean, many databases, there's overlap, right? So it's, I appreciate his thinking there, but I don't bite.
I thought he would be fine, but, and we're only going to talk about Weaviate as just a part of this, right? We're going to look at a much broader range of topics. But anyway, it was his choice, and sad not to have him here. It's kind of feels kind of weird, actually, to be doing this first solo episode after 36 episodes.
Yeah, well, let's see how you do.
Let's see. I'm not worried about it. You're a very engaging person. I've seen a lot of your videos while prepping, so I'm not really worried about it at all. But since we're on the topic, Elastic, the company, headquartered in the Netherlands as well, is that just a pure coincidence that these two search companies kind of came out of the Netherlands?
It's not even like the search companies. It's like more like broader in databases. So we have DuckDB is in the Netherlands. So Weaviate, we have the origin of Elastic. There's an origin story to Snowflake in the Netherlands.
I didn't know that.
Yeah, so it has to do with the math department of the University of Amsterdam.
Is that like a unifying factor here across all those database companies?
Yeah, it's very interesting that it is such a tiny country as the Netherlands. They have a founder of GitLab. I mean, we make it a little bit broader than databases, but it's also Dutch. I think so. The theory that somebody once had, which I forgot who told me this, but I find it very interesting. If you look at the Netherlands, if you go just back in history, if you just would cut off the Netherlands from Europe and you would just push it in like in the sea, we just couldn't sustain ourselves because the country is so small. I mean, we have a little of gas, and that's kind of it, right?
But it was a center of wealth and trade for 100 years.
Here you go. So one of the things that the Dutch got very good at is indeed trade. So what's funny, so people might not know this, but for example, if you're in New York, right, you see like, you have the Holland Tunnel, Brooklyn, that's from the Dutch word Berkeley, that kind of stuff. But also words like coffee and beer, those are all Dutch words. And that's because of the trading history. But the thing is, he said there's like a relation between focusing on trade and services and infrastructure and software. So the Dutch also good at like, in waterworks and those kind of things, the architecture. Yeah, civil engineering. Yeah. So there's like a parallel in the digital world with like civil engineering and trade and infrastructure software.
Because it's digital infrastructure.
Yeah. And then there's also like often if you work in infrastructure a little bit more in the background, not only as a company, but also the people at the company is like in some way. And that's also kind of aligns with like from a cultural perspective. So there's a couple of those kind of things that seem to be aligned there. And so for a relatively small country, it seems to make sense that that type of technology comes out of that country.
I always like to understand how someone got into being a tech founder. Like, we're going to talk about Weaviate and all that, but I'd like to understand, like, you as a kid growing up. What was life like in the Netherlands growing up? Were your parents tech people? Were they academics? Were they like, what was
No.
your background like growing up? Little Bobby here. We're talking little Bobby tables.
Yeah, exactly. So actually none of the above. So my mom took care of me and my brother just at home, and after that she became a teacher, or actually she was a teacher, like a kindergarten teacher, and then she raised us, and then she went back to teaching.
Did she homeschool you?
No. But she was she was taking care of us. That was like her. And my dad he was like a general manager of like a concrete factory. So it's like something completely different. So the funny thing is that often people see that my journey I'm now 38, so from like 0 to 38, that was like seemed that as unconventional, but that's not how it feels. I've been just always just doing whatever I was interested in. And when I was young, there were just early on two things, and it was like there was software. Like, so my dad brought home this old IBM XT, so this the black and green screen, right?
Yeah, monochrome, yeah.
Yeah, exactly. And there was like, and I must have been like, I think I was like in 5th grade or something, so in 10, 11, and music. So I was very interested in music. So when I went to high school, I was a horrible student in high school. Not horrible in the sense of like from just, in grades and that kind of stuff. I was just not interested in that, but I loved going to school just for friends and that kind of stuff. And there were two things that I was doing. Is I was playing music, but I was also writing software. And so the first time that I started a business, and in all fairness, it was very tiny. That was like, I never forget, it was when I was 15, because now I'm 38, so that means I'm born in 85.
Yeah.
So in 2000, I was 15, and people were starting to ask for websites. Yeah. The very basic stuff. And I was like, I can build you a website. And I remember that I went to the first, I never forget that. So I went to my dad. I said, Dad, I can build a website, but they want to know how much they're going to cost. So my dad said, like, so I mean, I'm Europeans in euros, right? So he's like, my dad's like, 500 euros. I was like, are you kidding me? Are they going to give me 500 euros?
Because to you, you're like, this is so easy.
Yeah, but it's like, if you fit, that was a lot of money. Yeah. Like, so I said, all right, so in back it's like 500 euros. And they were like, okay, done. I was like, really?
Should ask for more.
Yeah, exactly. And then I had to go. So in Holland, if you register a business, you go to Chamber of Commerce and you sign up, and you have like a one person. So that's how I got started. In the meantime, and then when it was time to go to college, I decided to study music. But while I was studying music, I was making money writing software. So that's like, and now we're 20-something, like early 20s. Yeah.
How old were you when the computer, this monochrome computer, when you got that?
Yeah, at 10 or 11.
I feel very lucky. My parents brought a computer home in 1986. Okay, so I was born in 78, so I'm 7 years older than you.
Yeah.
But so they brought a Tandy 1000, home. It didn't have a hard drive or anything, and it had a BASIC interpreter, and that's how I learned how to program in BASIC, and that's how I got started.
Same for me. So the computer my dad brought home had QBasic. So for me, that was QBasic, and I remember. So I was living in a small town in the Netherlands, and they had like a library. And in the library, they had this orange book, and I forgot the title, but it's something along the lines of, and it was in Dutch, but along the lines of like QBasic for kids. And I remember,
it's like sample programs.
Yeah. And I remember, I'll never forget. And I don't remember the QBasic syntax, but it was something like that. You had to write line 1. It was like input, and then what's your name, and then $name, and then underneath that was like print or echo. I forgot the syntax, and then hello. And then $name. And I remember that I did that, and I was like, holy shit, this is like magic. And it's like, I was like, wow. So the funny thing is, so sometimes people ask me, why didn't you like, study like, CS or that kind of stuff? That was just because for me, the computer and software, that was just a creative outlet. That was how I was looking at it, and that was how I was using it. I was not, when you're like young, you're like, a couple of years later, 15, 16. I mean, it's like, if I now see like boys 15 years old, I was like, it's a miracle that you know how to tie your shoes. I was like that too. So I was just playing around with that stuff, right? And I was making music. I was making music on the computer as well. I was building a lot of websites and that kind of stuff, and I made some money off it. So it's like that was I just love doing that. And I was just making stuff. I think that's like a theme through my life. Just I like to make
Yeah,
stuff.
you're a builder. You're a maker.
Yeah, yeah.
There are a few moments in my life where I distinctly remember the moment of it and how I felt. You know, I was thinking about this last night. So, like, the first time I used an iPhone, I remember thinking, this is game changing, right? The first time I rode in a Tesla, this is game changing. The most recent one was the first time I used ChatGPT to write code, and I saw how good it was, and I thought, okay, this is game changing. So you had that moment the first time you wrote a basic program. I'm curious, do you have other moments like that in your life that you can think back to where you're like, this is a paradigm shift, I've seen it, nothing's ever going to be the same again?
Yeah, so related to technology or in general?
Just in general.
So let's take music for example, right? So I was a big fan of the Peppers, right? Red Hot Chili Peppers, and I had a teacher who noticed that I was. It's important to know here that I studied bass guitar and I play bass guitar, and that's the. So I was listening to the Peppers, and one of the
that's Flea, right?
Yeah. And one of the things that I was doing was that I was always forwarding to like guitar solos because I love like drum, bass, and then the guitar solo, right? So you had that album, Blood Sugar Sex Magic, and then you had like, God, what's the name of Funky Monks or something like that. And then I went to the guitar solos, and I had a teacher, and he said like, well, if you like that kind of stuff, I'll have something else for you. And he gave me like a CD, a CD, like a ripped CD, of course.
Yeah, sure.
Of like a Fat Time from Miles Davis.
Okay.
And then that number, Fat Time, so that's with Mark Miller on bass. And then at the end, you have Mike Stern. And he also had a guitar solo, but not 30 seconds, but like 6 minutes.
Wow.
And the band, and I believe it's like Billy Cobham or something on drums. And there was, and I was like 15 or something. I was like, holy shit, what is this? And so I had a couple of these things in music, right? So that kind of stuff. And when I got a little bit older, I did it with classical music, with Stravinsky. And in the end, if you're deep into music, we all end up with Bach. So but then
it all starts there, yeah.
Yeah,
sure.
I was a little bit older. So those kind of eye-opening moments in technology, I had it indeed with like just being able to write code, not with the internet because I was very young when we had the first. So for me, having an internet connection was a little bit status quo. There was like there's
The first time I got on the internet, that's another one of my moments.
yeah, but
Because I ran a bulletin board system. I ran a Renegade BBS, and I was big into like local dial-up bulletin boards and stuff. So the first time I got on the World Wide Web, I was like, okay.
Yeah, so that's something I don't have because I was so young when we had an internet connection at home. That was just a thing we had, right?
Yeah, you're in that first generation of people who grew up with
Yeah,
it.
yeah. But I absolutely with mobile phones as well, 100%. Cloud, just being able to just spin stuff up and build stuff, that was also an eye-opening moment. But also, for example, in literature. So, I mean, I was like, 16, 17, and I was like this smart ass, typically those, what I mean.
I know exactly what you mean. I was one.
And I remember, so I was like, okay, I want to read Kafka, right? So, and I was like confused about it. And it was actually
What is this metamorphosis thing?
Exactly. And I didn't get it. And it was actually a friend. He said like, are you reading Kafka? I said, yeah, because and he said, do you actually understand the metaphors? So I was reading the process, and he was like explaining the metaphors to me. And I was like, holy shit, can you do that? So I learned that everything that you do, doesn't matter what it is, doesn't matter if it's starting a software business, doesn't matter if you play in a band, doesn't matter if you want to be chef, doesn't matter, whatever. Anything you make, there's this concept of you can go to a place, right, where it's the best.
Yeah, sure.
And now, when I say this now, it sounds like such a obvious thing, right? So, duh, of course. But back then, when you're like 16, 17, that you discover these kind of things. And I was like, so the cliches are, in tech, it's the Bay Area. It's like if you do jazz, you go to New York. If you want to be a chef, you go to Paris or to Tokyo. No, and so on and so forth, right? And
that centers of excellence for whatever.
Yes. And that was what I discovered then, that I was like, okay, so there are like a couple of things that I guess like two things that I was like gifted with, that insight in music and a natural understanding of the working with software. And I was like, oh, I'm just going to figure that stuff out. And then I just went on wandering around, meeting people, building stuff. And then when I was studying music, I did a couple of jazz projects that I'm super proud of, or creative projects. They're also still online. So, I did a project with the drummer Billy Martin and Kung Fu, and I was like super proud of that. And I paid for that by writing software. But then I was like early 20s, and I was like, I want to do software really full time, because I felt that was just, I had a friend, or have friends, a jazz person. His name is a piano player. He's now in his 80s, I think, jazz piano player. When he told me these stories about the 60s and the 70s, how the music scene, what was happening there, I just knew that was just, especially 10 years ago, not happening at all in music, but it was in tech, right? So I was like, I want to be part of something that's happening in my lifetime, where I feel that what happening in the 60s and the 70s in music, that's now happening in tech, and I want to be part of that. And it happens that of the two gifts that I have in music and in software so that's why I decided to fully focus on software, because I just wanted to be part of that. Just because I felt I can make more things there now, because from a cultural perspective in general, this is the time. It's the time of tech right now,
Absolutely.
and not the time of music.
Yeah, absolutely. So I'm also a musician.
Oh, really? I did. Oh, no, I know, a trumpet.
Trumpet, that's right. So I'm on the board of an orchestra in Queens, and I play trumpet in the orchestra, and music's been a huge part of my life.
But classical, or?
So I didn't study it in a conservatory the way you did. So I kind of did the opposite of what you did. I studied computer science, but all of my social life, all of my friends, all my roommates, everything I did outside of engineering classes, I was in the marching band. I was the president of the marching band. I played in the wind orchestra. I played in the University of Jazz Band. I played in, little gigs here and there. Like, that was my whole life in college. And then when I got out of college and I moved to the Bay Area, as you do when you study computer science, so I moved to the Bay Area in 2000 when I finished school. All I did for my social life outside of work was play music. So I was gigging all over the Bay Area at the time, and any human endeavor, there's like hierarchies of things that you can work your way up in, right? Just like you work your way up in a company, you work your way up in the music scene, right? And you start out playing community theater, and then you make friends, you make people like, oh, that guy can play. I'm going to call him to sub for me. And so there's this, in the Bay Area, there's this like hierarchy of trumpet players.
Yeah.
You start meeting them, and then when they move up, or they'll sub for the next person above them, and then they call you to sub for them at whatever gig they normally would be playing, and you kind of go through this. So I was taking it super seriously for the 5 years I was living here, and kind of working my way up through that world. And yeah, just playing everything: classical, jazz, theater, everything.
Yeah, fantastic. It's a fascinating world, and I of course have still friends who are like in it, right? So it's fascinating to see, but it's also nice. So hey, you mentioned in the beginning. So I studying in the Netherlands, and then I went to when I did my master,
You went to Berkeley.
Went to Berkeley.
Yeah.
And there are now people that I studied with at Berkeley that are now like people that you every now and then you see these names combined.
Oh, sure.
Make amazing stuff, and I go, that's just.
Well, people might not know, he's not talking about Berkeley as in UC Berkeley in the Bay Area. He's talking about Berklee College of Music in Boston, one of the top conservatories in the world. It's kind of like a Juilliard, but in Boston, right?
Yes, and what's so nice, so one thing that's actually, it's funny you say that, because always, especially in the Bay Area, you always need to explain.
That's right.
Berkeley, double E, not EY. What I learned about at Berkeley, so Juilliard is really focusing on quote-unquote traditional classical music or classical jazz. So really the old jazz methodologies, I guess.
Yeah, bebop
yes, bebop, that kind of stuff.
Yeah.
But actually, I would not say fusion, right? So really, it's like, I think it kind of ends at bebop, right?
Oh, okay.
But it's some jazz fans who are listening to this might now go like disagree with me. But the thing what's so nice about Berkeley is that Berkeley is really focusing on contemporary music. So you could have theory class, and then they could talk about like, I don't know, the usage of harmonic minor in something. And then the teacher would use an example of Sting, Mozart, and Charlie Parker.
Okay.
Just to illustrate how you would use that, right? And that was, for me, I loved that. So Berkeley really leans into like contemporary music, and then just whatever it takes to make whatever you want to make. That was like a very eye-opening. So the big difference is like, you can study the classics, right? Or you can just study the contemporary stuff and then try to make something new. People have very strong opinions on how to do what. It's not very different as we see like with people writing software, right? So there's some people that think like you really need to be able to go into certain a certain level of detail or have a certain understanding of what good software means. Whereas that other people say like, nah, I just want to quickly build stuff, and that's how I express my ideas. And I think there's a truth to both.
Yeah, but I think you can have an appreciation for someone who does it at the highest level in anything.
Yeah, and this is something that I also learned, and this might sound like a weird term, but when it's very competitive when you're regardless if you're in music or software, that kind of stuff. And I noticed that people or musicians who are very successful, or software often entrepreneurs that are very successful, or people just are very successful software engineers at companies, what they have in common is that they're really nice people.
Yeah.
They don't have to prove themselves anymore. They already have. The dues are paid, right? So it's like and I mean, of course, not 100%, but like in a high majority, like a lot of people the majority are just nice people. And that's a very common pattern that I see in the arts and in software.
Do you think there seems to be a lot of overlap between people who are in software and people who are in music? I went to engineering school, but almost every person who was in the music program was an engineer. We had very few music majors. And so a lot of people that I know who are in tech also either studied music, not maybe at your level, but they played music in high school, maybe they played music in college, or they keep playing. Do you think that there's I hear people talk about it, but I've never actually heard an explanation for why that is. And the only thing I can think of is like music is another language, programming is another language. And so maybe if you get good at one, it kind of trains your brain to think about languages. And I don't speak a foreign language. You speak at least two that I know of besides that. But I don't know. I feel like there's an overlap there in terms of languages.
Maybe
and we even use the same words to talk about it. We talk about like when we speak in phrases. When we play music, we play in phrases. Like,
yeah, maybe. So I mean, that sounds plausible. What I also think is that the structure of music. So still now, if I write software, I mean, with my role right now, I don't contribute to the core anymore, right? One, we have people that are like way better than me at that, but secondly, I just don't have time for that. But I do still write like a lot of software because I want to try something out, or if I just need to do something.
You still tinker?
Yeah, sure. And every new Weaviate release, I always try it out, or I try the new features just to play around with it. But then when I have an idea, I go. So I have the concept in my mind, and then I kind of know. Oh yeah, I'm going to capture this in a function, and then in a function, and then I need to have that. Oh, just look at a little bit of documentation. Oh yeah, and then I have the solution. How that clicks together is very similar. That if I see a G minor 7, a C7, and then based on the melody, I know it will resolve to an F major 7 or an F minor 7, right? So it's like
you see the patterns.
You see those patterns, and that way of working in the brain is very similar to me, at least. So I do see. So hey, you also mentioned the TEDx talk that I gave, which is about the language philosophy plays a role in that, which is like a hobby of mine, I guess, analytical philosophy. And in my brain, that works very similar as writing software or writing music.
Well, there's a logic to it. There's rules to it.
The rules and the logic. So I think maybe that's it. Maybe it's the combination of the rules and the logic. It's pure logic, and that's within a set of given rules. And I like that. I just like that in my life as well, right? So it's like I don't like. So for example, I travel a lot. And so if I go to New York, I know exactly where I'm going to have my espresso. I know exactly where I'm going to eat the first night. Same in SF, same if I go to Amsterdam. It's like I like the boundaries, right? The set boundaries, and that you can be creative within that. So I think it's somewhat related to that.
Yeah, you talked about the fact that there's finite means but infinite possibilities. Like there's only so many words in the English language. There's only 12 notes in a music scale, but there's no limit to the number of songs you can create. Same with code, right?
Yeah, so I think that comes from, for those listening who don't know, so I think it comes from Noam Chomsky, that he said that the beauty of language is like you have infinite possibilities with finite means. And the case that I make in the TED Talk is that I'm saying like, because we write software in human language, not to be confused with what we now can do with LLMs, but I meant more just good old-fashioned software, engineering. If that is true, that we have infinite possibilities with finite means in language because the language changes. That means that we can come up with an infinite number of ideas we can express in software because we use language to write software. And that was kind of the point that I wanted to get across. So I think it's a hyper creative medium, right? So we can, whatever we can come up with, we can write down and execute.
Well, it's weird because we are limited by sort of the physical world still. I mean, yeah, you could write software that does anything, but before we had these big GPUs, we didn't have LLMs, right? So we sort of needed like these physical innovations to occur before we could express certain ideas. What's another example? Like, Steve Jobs always wanted to be able to put music in his pocket, but it wasn't until hard drives and storage got miniature enough that he could actually make an iPod.
Yeah, but I, at the risk of now sounding too esoteric,
Esoteric's good.
Okay, so I when I talk about these kind of things more from a if you go into that philosophical realm, I leave the whole practicality out of it. So the Steve Jobs example of I want to be able to put music in my pocket, right? The reason he could say that was because he knew that was possible, right? So it's in like oh yeah, it's more it was the idea that was important. Like, hey, you can walk around with a library of music in your pocket, meaning like you can take the music everywhere you want. That was, in my opinion, way more important than being limited by that you couldn't do it. Even further, I think that if we now create businesses and that kind of stuff, especially in the early days, we thinking about what's not possible that's just not helpful. So it's perfectly fine to just write down a whole idea and then just completely ignore what's not possible. May I give an example?
Absolutely.
Of course, my time is like 99% focused on Weaviate, but in 1% time, I also read stuff that I'm excited about or that I see if there's like, might there be like product or business opportunities in the future. And like 2 years ago or something, I was introduced to a paper called Mesh Code. And Mesh Code was the paper that was written in the UK at the University of Kent. What the paper basically described was like, it was a theory around storing the binary information in protein, in taline, in the brain. And so the research said that maybe that's how the brain encodes
like memories. Okay.
And I got interested in that, and I just read the papers. The guy published another paper, so I was reading this too. So I started to play around with that. I was like, hey, that's super interesting, because if we just leave the memories in the brain out of it, but we just say like, hey, we can take taline and we just encode information in it through light and those kind of things, that's like significantly cheaper than, storing a petabyte binary in a protein is significantly cheaper than doing that on
and very small too.
And very small too.
Yeah.
Then I write that down. So and then I just during a weekend or something, I just spend some time, write it down. And I just try to envision what that might look like in the form of product. But I don't care about what's possible or what's not possible. I just first write it down, and then that's something that sits then in my brain. And then by writing it down, I kind of offload it from my brain.
Right,
and it sits just somewhere in my Google Drive. And I have all kinds of those kind of ideas, right? And I just write them down. But I feel very comfortable not being concerned about what's not possible, because if you're like, that's probably not possible, then...
Well, I didn't mean it in that way. I meant it more in the sense of like, until this new technology is invented, there's like ideas we never even thought of as being possible.
Yeah.
Not that we thought about them, but they weren't possible, but like, it's kind of like when a new word becomes a thing. Well, now I have a new thought that I couldn't even think of before because there was no word for it.
Exactly. And I think we can even do this in a little thought experiment, because if I'm now saying... So the example that I just gave, right? If we just have like a little one by one where we have like all these, we structure all these proteins on it, and then through light or laser or something, we can read it and we can write it. That doesn't sound too science fictional, right?
No. It sounds possible.
Exactly. And then and there's now probably somebody listening who knows way more about that stuff than I do. But then that this person that must say, oh yeah, but we can't do that because X, Y, or Z. But it doesn't sound unreasonable. And then going back to the previous thing, right? So it's a infinite possibilities is finite means. And the first thing we do, like Jobs did with the iPod, we talk about it. And then by talking about it, we think about it and those kind of things. So
I tell I have 4 kids, but my 2 older boys, we sometimes just talk at night, and I'm teaching them how to program. They're learning Node.js.
Fantastic.
They do the Khan Academy. Just they work through the exercises. They want to learn how to program. So we're working on that. But I was telling them, like, by the time you're my age, people aren't going to be writing this kind of coding anymore. But I told them about CRISPR-Cas9 and the fact that people are programming with genetics. And, like, you know, that's going to be kind of the future of programming, is creating, who knows what you're going to create, new species, cure diseases, but you'll be programming with genetics. And that's maybe something that because here's the way I think about it. My parents were not engineers. They didn't know anything about computers. They bought this computer, but the one thing they did, and the huge gift they gave me, was they looked at it and said, I think computers are going to be the future.
Yeah.
So I want my kids to learn that. And in the early 80s, that was just not feasible for most people. My parents were not wealthy. To buy a computer back then was a huge, huge expense.
Yeah.
Like buying a car. But they did it because they thought it was going to be important for us. So I always want to look ahead and say, like, what is the equivalent of that I could do for my kids to say, 40 years from now, this is going to be huge. I want them to start thinking about it now.
So that's super interesting. I don't have any kids, but I sometimes have this conversation with people. I have a slightly different. If I would have kids, I have a slightly different position. So that I more think like that I would say, like, it can be anything you want. I think there are two positive ways of doing it. Like, I mean, of course, the negative ways, by the way, there's also something interesting to say about that. But the positive ways, like, so, or you can, like, nudge, like, hey, what's that new thing? And then nudge in that, make it available for not even for your own kids, but like for children in general. Or you can say everything you want. So that there's no cultural limitation on what people want to do. So, you know, you want to do ballet, great, go. You want to do, right, comic books, great, do that, right? So that it's a.
Well, I think exploring interests is good, and encouraging them to explore whatever's interesting is good. But I'm always just trying to see it. And maybe there is no answer. Maybe the computer was so transformational that those types of things only happen once every 100 years or once every 200 years. You know, the printing press, the this, the that. And maybe there is nothing as transformational as the computer happening now, that, like, you just have to know this 30 years from now. Everyone's going to need it.
Yeah, exactly. And also something I find interesting with, like, learning, because you asked, what's so interesting is that so when I was young, it was like, it was not, I mean, growing up was not all fun, right? So there was, like, some things when I was young, they were just, you know, at home, they were just, like, not cool. And the interesting thing is that gave a kind of an energy, or like a fire in the belly of, like, whatever I'm going to pick up, regardless if that's music or business building or software, I'm going to make sure that I'm going to be good at this. That's also something that I find fascinating with people, because a lot of people that I meet that are successful in what they've been doing, they all have, like, a story, right? So something that put on the fire. exactly, the fire in there. So it's
so what were some of those negative things that, like, lit a fire under you?
So my parents got divorced when I was, I think, 14 or something, and that was no fun. That was like one of the, like, the ugly ones.
That's probably very disruptive to your life, yeah.
Yes, and that the ripple effect of that was like, there was, like, at least a couple of years, and that has, like, during high school, a huge effect on me. But that also meant that I was, like, I believe I was 16 when I left the house. So, and I was living with a friend back then, and that meant that I was very young, that I had to take care of myself, right? But there was also some kind of I was, like, angry about the whole situation, and that kind of lit that fire of, like, I'll take care of myself, right? And not a little bit, you know what I mean? So that was like that stuff happened. But what was interesting was that a lot of people that I met had, like, that were just had a similar fire, had similar stories, and I was like, that's fascinating. I read the book Anti-Fragile from Nassim Taleb. I love his work when he explains the concept of anti-fragility, right? So where he says, like, so for those who don't know, so, like, if you drop a cup on the floor, it's fragile because it breaks. If you drop,
like, a metal thermos or something, yeah.
How does he call it? It's robust, yeah, because it doesn't. He said, but for example, a muscle, if you go into the gym by lifting weights, right, you break, quote unquote, the muscle.
Yeah, you tear it down so it builds up stronger.
Exactly, it builds up stronger. And he said, like, you even see that in psychology. So you have, something like fragility in the form of PTSD, or sometimes you have people who just bounce back. But you also have something called post-traumatic growth. That's actually an existing medical term. So where people go doing a negative experience in life, but they actually come out stronger on the other end. And I think, I don't want to make it too heavy. And because I know also a lot of young people in this world experience way significantly worse thing than I did. But I do feel that it somehow gave me some kind of mental strength to just really go, as far as I could.
It's weird because if you put most people, if you put them in a really stressful, bad situation growing up, it's gonna result in a bad outcome, right? Then maybe they'll grow up in a life of crime or depression or whatever it is, right? Bad relationships, etc. But some small percentage of people come out of it stronger.
Yeah.
And we don't know why. You put, people in the same exact situation, same household, siblings, whatever, but like some of them end up bad and some of them, become CEOs, like do amazing things, right?
Yeah. And that's the interesting thing because, for example, also the level of stress you need to endure and those kind of things is just, I don't think that is healthy per se, but for every reason we do that. And I also cannot imagine life not doing that.
Right.
I just can't imagine not doing that.
Right. We're not just going to go live on the beach and be happy at the pool.
Exactly.
Can't do it. It just doesn't work for our brains.
It just doesn't work. And it's interesting because I do think that you can all lead it back to, childhood and those kind of things.
Yeah, I didn't go through the same situation you did, but I grew up in a very small rural farming town. I mean, I literally grew up, I was like milking goats, right? As a kid, and my grandma would say, I'm going to make a chocolate cake, go steal an egg from the goose. And I don't know if you ever try to steal an egg from a goose, but they bite you,
Yeah, they do.
Can I just get 2 eggs from the chicken coop? It's way easier.
Yeah.
No, go out and get it from, I think she wanted to teach me a lesson or something, I don't know. But that's how I grew up, and I hated it. I did not like this life. Yeah. And in high school, I worked at Wendy's because I needed to pay for all my computer gear and run my bulletin board and everything. And this is a very hard job. I think every kid should work like a service job, a fast food job or something like that. Because I was surrounded by people who were in their 20s, 30s, and 40s working a minimum wage job to support their family. I mean, they were doing a great job. They were supporting their family. But they were I did not want to be doing this the rest of my life. And so for me, I left when I was 17 and I went to college. That was what fueled me, was to never end up back in that situation.
Yeah.
And to have a different kind of life and a different kind of future. And anytime college got hard, or I was just like, oh, I really don't want to do this, or I'm exhausted or whatever, I just think back to like what it was like working at Wendy's and how I never wanted to do that again.
Yeah.
And that gave me the fire.
Yeah, that's so interesting because it's always this flight response. Like it's like, I don't want this.
Yeah. It's avoiding pain. Yeah.
Yeah, I just don't want, I want to go somewhere else. And I absolutely don't mind fighting for it, right?
That's
to go
right.
somewhere else, but not this.
Human beings only do things for one of two reasons. They're seeking pleasure or avoiding pain.
Exactly.
Right? Everything you do can be boiled down to one of those two things.
Yeah.
And I like to avoid pain whenever I can. but by doing that, I'm doing something else that's painful. It's like going to the gym is painful, but it's like, it's a good kind of pain. So there's pain that we like and pain that we don't like. It's really interesting.
Yeah, it's fascinating. It's fascinating. And it's a, how should I say? It's just, I mean, the older I'm getting, the more fascinated I'm in these kind of stories. Like what's that background? Why is it the way it is? Also, can you design it in a certain way? Because in the end, everybody wants like young people to do well, right? So it's like can you in a maybe working at a Wendy's is like the good way of like feeling that quote unquote pain and then go like, okay, now I want to do something something else. Or I find that stuff just very the whole psychology behind it. I find it very, very interesting.
I make my kids work. I mean, from the time that they were very young, we made them work, and do chores. And you want to buy things? Like you gotta, you have to work, and then I'll pay you for it.
Yeah.
And how much you get paid depends on how much work you do. They're like, I need more money. Okay, well, I'll give you more work to do. They're like, no, I don't want to do more work. No, well, that's how you do it. You either have to do more work or you have to do something that's more valuable to the person who's paying you.
Yeah, but this is super interesting, right? So one argument, this is a form of love, right? So you love your kids, and to show that love, you make them work. I also love my girlfriend, but I don't make her work. you know what I mean?
Well, you're in a different relationship.
In a different relationship, but that's what I'm trying to say. It's like, that's what I meant, what I find so interesting with children. It's like and again, I'm not a parent, so you know this better from, of course, from experience than I do. But it seems that to show true love to your kids, you want them to experience what it is to go through that, to work or do stuff to get to that moment of pleasure, right? So that now you can buy something, now you can do something, and you enjoy it more
Because
if
you
you
worked
worked
for
for
it.
it.
Absolutely.
Yeah,
If it
exactly.
was just given to you, you wouldn't appreciate it.
Exactly, and that's I love that stuff. I like the psychology of that. It's fascinating.
The other thing I make them do is however much I give them, I make them take 20% aside, and they have to invest it in the stock market.
Oh, I love that.
And they get to pick what stocks they buy. Schwab has this thing called stock slices, so you can just buy like $1 of any S&P 500 stock. So I set up a Schwab account for each of them. You know, every month I wire whatever $12 or whatever it is that 20% of their stuff, and I let them watch it grow.
Oh, fantastic! What kind of stuff are they buying?
Oh, they buy Apple, they buy Google, they buy Nintendo, things that they know, but I don't care what they buy. Costco, because we shop at Costco. One of them bought some Costco stock. Amazon, they have a lot of Amazon stock because I worked at Amazon. And, you know, during COVID, every day was like 5 Amazon boxes coming. So that's kind of what they buy, and I don't care what they buy. They pick.
I love it. But even here, so you can make a little money, but you can also lose a little bit of money.
You know, they watch the swings, right?
And they learn from that.
Yeah.
So you learn like, oh no, why did I lose? Oh, well,
I show them the swings and how it goes down, but if we zoom out, you know, then it's
it
going
goes
up.
I love that.
Yeah, and never touch it. I tell them never ever. For the rest of your life, you can never touch this money
Yeah. Oh, I love that.
until you want to buy a house. That's the rule. You can only pull this out when it's time to buy a house.
Fantastic. I love that.
They might grow up and this is what they're going to tell their psychiatrist when they're 40. My dad used to do this and it was so painful.
Every month, $12.
Well, let's talk about Weaviate a little bit. So what's the genesis story of Weaviate?
I'm working with embeddings for now almost a decade now. And I started working with Glove. And the reason I started working with it was because I was running my little software consultancy firm, I was just a one-man band basically. And I was hired by a publisher of scientific, they were publishing scientific papers, that kind of stuff. And one of the challenge that they had was open access was like, right? So a lot of scientific papers became open access. And they asked the question like, okay, what can we do for our customers different than, charging for these papers? What other services can we build? And I was not working on those kind of services, but there was the data science came up. So they hired this guy, Paul is his name. He's now a professor of data science at the University of Amsterdam. And he set up these data science calls in that company where you could just dial in and just watch whatever they were working on. And that was for the first time that I saw embeddings. Word embeddings, I think that was Word to Vec or Glove, I think Glove. I was fascinated by that. There's a word that I used earlier in our conversation when I was talking about that Miles Davis record, that the word magic that I used. And for me, word embeddings were like magic. It was like, there's something about calculating with the words, right? And then getting a result out of that is where there's an intrinsic understanding that that's the correct answer.
A semantic meaning.
The semantic meaning, yeah. And I found that beautiful. And so I started thinking around with that, playing around with that. I was a part of a community called Google Expert Community. And then they, you can talk about technology that they have and that kind of stuff. And I was invited for Google I/O back in 2016. And it was actually already in 2016 that during the keynote at Google I/O, Sundar Pichai said like, hey, we're going to move from mobile first to AI first. So they were already talking about the stuff in 2016, and then it took a dip. Now, of course, today they're like fully back, on the bandwagon. But
AI, everything, yeah.
He mentioned, I even fact checked this later, and there's still some old articles from 2016 where they quote him on saying that, and I was like, I know what they're doing. And important to bear in mind, by the way, for people listening, this is before like the Transformers paper.
Right.
It's all before.
Early days. The LLMs didn't exist.
And I was like, oh, I know what they're doing. They're using these vector embeddings to index the web or something like that. And then I got this idea. It's like, well, if they do it, then other people probably going to want to do that too. And that was like how the concept of Weaviate was born. So back then it was just taking centroids of paragraphs, storing them, searching through them. And now something important happened. So how did we store that information? Well, we stored that in a back then already plugin to Elastic.
Oh, okay.
And it was Annoy. So he's actually on our advisory board. Eric is his name. He wrote for Spotify this algorithm Annoy, and it was like a plugin into Elastic. And then I met my co-founder, Etienne, who's currently the CDO of Weaviate, and he said like there's a problem in the sharding mechanism of Lucene. So that was where the idea was born. Like, let's build the database from scratch, where we really focus on the vector index itself and not be limited by existing sharding mechanisms and that kind of stuff.
So was it because just some implementation detail of the way Lucene broke the shards up made it inefficient to search the vector space?
Yes, that is literally what it is. You have different ANN algorithms, approximate nearest neighbor algorithms. There's also that website, annbenchmarks.com, which is like where you see all these different algorithms. The algorithm that we use, and of course it evolved, right? But the original is the HNSW, so that's a graph-based algorithm. The reason, sometimes people ask like why that algorithm and not one of the quote-unquote better performing algorithms. That's because the algorithms you see on the website are, the benchmark on the website is like who's the fastest, not which one can we use to build a database with. Because if you build a database, you want to have CRUD support. And most of these indices are immutable. Right. So then you build them and they're super
just like
fast.
a Lucene index.
Yeah, exactly.
Right, you're always rebuilding them. You're not updating them.
Exactly. And that's not what HNSW is doing. So with HNSW, you could build a full CRUD support vector index. Out of that, we started to deal with filters that people needed. We started to use hybrid search that people, but all from the starting point of the vector index. So we also know today, and this is a hot topic, but because it's like there's a lot of research being written, and it's important to say today, that's just an unsolved problem in Lucene. Right, so if you scale up your use case, at some point it topples over. And that's the reason why not only us, but also other people figured out, hey, if you want to build a vector index, you need to build it in a different way than extending it in Lucene. So that's kind of where that idea came from.
Where'd the name Weaviate come from?
Weaving the model and the database together. So it's like this is something we're still working on as well. So I strongly believe, so if you take a generative model now, for example, is if you look what's happening under the hood, and especially with the open source models, if you just have an afternoon to spend, just go to the Transformers library, and then if you use a generative model, if you use something like GPT-2, which is relatively lightweight, then you see that there's a function that's called generate. And then if you go in generate, you can dive deeper into the actual attention mechanism and see how it works. And what's very interesting in that is like, a lot of vector embeddings involved in that. So what we do now is still very primitive. So weaving, if you will, the models and the database more closely together is something that's happening. That's also something we're working on. This is also why I talk about Weaviate as being like AI native. And what I mean with that is that you really start to intertwine with the models, right? So it's not traditional way of storing and searching through information. It's really in harmony with the models, which is very different. And that's also why, yes, it's also what we said in the beginning. Yes, technically speaking, Weaviate is also a search engine. Yes, there are some overlapping use cases, but the new stuff that we see happening, and I'm not even talking about RAG stuff. I'm talking what comes out of that, right? Generative feedback loops, that kind of stuff. You just need dedicated infrastructure for that. And that's what we're building.
But models didn't exist when you started Weaviate.
It was a model, right? So to say, in the end, the glove is a model. It's just what people do. It's like what we didn't do is we didn't do inference on the model. So, but theoretically speaking, we could do that. Basically, what it did was because it was only like a corpus of words, the famous bag of words. So how many words were in there? I actually don't know. It's like, but let me, I don't know, 50,000 or something. Okay. I might be completely off.
Words in English language, you mean? Yeah, something like that. Yeah.
Yeah. So and what was very interesting to see. So you saw like particles like were very much in the center of the effects. But what they basically did was that they trained the model, did inference on the model for all those 50K words or whatever the number is. I also remember from back in the day that you had to set so you took a corpus that was often Wikipedia. Back then we thought that was a lot. And so you took Wikipedia and then you created the bag of words based on threshold, how often the word was in the total corpus.
Yeah, like a term frequency.
The term frequency, yeah, exactly. And so then you train a model, and then it did inference on the back of words, and then out came a CSV file with word embedding, word embedding, word embedding. But theoretically speaking, you could do it real-time inference, right? We just, okay, word, what's the embedding for that word? So that's how we do it now. But theoretically speaking, it's the same thing. It was just, there were like a lot of abstraction layers between inference and storing the embedding in the database. Like how we remove that now, that we do direct inference on the model and store the embedding in the database. That's going to move even closer together for the generative models, where we start unpacking those functions and say, like, every time an embedding is needed, we can do that directly in the database. So for example, if you look at the generative models, so one way how they speed them up is something called the KV cache.
Key value, yeah.
Based on, during inference, if you can cache certain things, right? That's now done just in memory, but you could also do that in the database. So if the model is, people, there's the camera. So because the model is here and the model is there, we just keep removing steps and bringing the database and the model closer to each other. That's what I mean. So, and back in Glove, there was inference. It was just very primitive because the inference happened, we stored it in a CSV file and then brought it to the database. But that's just a in-between step.
How do I make sense of the space of all of these things? Because like in my mind, I think about, okay, there's these established players. Postgres has vector stuff. Mongo has vector stuff, right? And they're just building it in because it's, people want it. They're already using those databases as a system of record.
Mm-hmm.
So there's that. And then there's pure vector database companies. So let's say Weaviate, Pinecone, things like that. And then, and maybe this is wrong, but this is how I've categorized it in my mind. And then there's these like platform players that are building a bigger, I don't know, a bigger ecosystem. So I have like Elastic they have a vector database, but they have all this other stuff around it. Vectara has a vector database, but they have all this. Am I thinking about it right in these sort of three categories of things, or how do you envision this space?
So to make sense of all of this is like, let me first preface this by saying, like, I think this is amazing what's happening right now. The example that I always gave, that was just before COVID, the first Weaviate meetup that I ever gave was in New York. So I set up the meetup.com page because we used that back then. And I was like, and we were talking about, back then already about like knowledge graphs and that, nodes that you could, discover with vector embeddings, that kind of stuff. And I went to New York. I hired this room. I forgot the name of the service. And took myself some pizza, some beer, some drinks. And exactly 0 people showed up.
Oh,
right? So yeah, it was
the first meetup is always brutal.
Yeah, exactly. So that was very painful. So nobody cares. Fast forward to today, a lot of people care. That's great because in the end, the vector embedding is a data type. Funny thing is, we can store that data type forever because it's just an array of floating points. Nowadays, it's evolving into something else, like an array of binary array or array of integers, but it doesn't matter. The interesting thing, of course, it's in the search index that we're building, right? So it's very technical, right? So that's just what it sits at the heart. And what you try to do if you have a database, so regardless if you any database, you take the existing structure of indices that you have and then you add a vector index to it. A lot of them, as we mentioned, use Lucene. So a little bit of shoehorning is happening there, but that's fine. And then people can start to work with it. But on the other end of the spectrum, something else is happening. And that is everything that has to do with the developer experience. The way that we interact with these kinds of databases, the types of applications that we build with these databases, the stacks that start to emerge around these databases, completely different.
Yeah, I mean, my background, so, I came from MongoDB, and the reason they were so successful was because they made a great developer experience.
Exactly. And that is also what I find so tremendously inspirational in like how MongoDB's been doing that. The irony right now is, and that just makes me chuckle, is that if people go like, yeah, but you can also store a vector embedding in Postgres. Yes, you can also store JSON object in Postgres.
Right, and it's not very good at that either.
That's my point.
Right.
But that's fine. And if people want to do that, they should. My point is it's the developer experience. So what made, in my opinion, you know this better than I do, but what is part of making MongoDB famous is the mean stack.
Yeah.
Right. So let's unpack that a little bit. Right. So then of course you have the database. You have Express, that is for the front end developer.
Or the back end.
Sorry, the back end.
Angular for the
Angular
front
for the front end. Sorry. Frameworks are an interesting topic in general to talk about. And of course you have the node also in the back end, right? So if we unpack that, what are we looking at, right? So we see a lot of interesting things, right? One is very focused on the web and app development, right? It's very focused on JavaScript,
Right.
because that's what we see with Node. It's interesting what we see with the frameworks, because the only thing in the mean stack that's not around really anymore is Angular,
Yeah,
right?
nobody uses Angular. It's all React or
React,
something
but
else.
still, but
Same idea. It's another JavaScript front-end framework. Yeah.
exactly. So now let's do the same thing for...
Elastic had that too, right? They had the Elk stack.
Yeah.
Right. So these stacks being
Yeah,
part
yeah.
of a stack that resonates with people seems very important.
Yeah. Now let's look at the stack that is emerging. It's not there yet, but what's emerging for AI. Well, first of all, the language is not JavaScript.
No,
It's Python.
because it came out of the machine learning world, and it was all Python.
Yeah, God knows, right? So I guess so. I mean, if we try to learn from history, the reason that we had JavaScript in Node was, of course, because the browser was so probably that makes sense.
It was all PySpark and all these different ML libraries in Python.
We have completely different frameworks in our space, right? So the famous frameworks that are around in AI are the LangChain of this world, Llama Index, stuff that Unstructured is doing, that kind of stuff, right? And now new stuff, DSPy, and so on and so forth. So the language is different. The frameworks are different. The backends are different in the sense of like we need to deal with model serving, model inference, and that kind of stuff. And the databases are different, how you interact with them, right? So it's just a different way, it's a different structure how you work with them. So that developing, so let me give you a practical example, right? So if you want to do a hybrid search, that's like 4 lines, 5 lines of Python in Weaviate. It's more than 100 if you want to do that with MongoDB right now.
Mm.
So if we all agree on the fact how important developer experience is, then that is just because it's a different way of how people build applications. That is what I call the AI native way of building. So that's why I'm saying like what MongoDB did so well and with such an inspiration for us for the app developer, we aim to do that for the AI native developer. And yes, I understand that there's some overlap here and there, but I see this, yeah, it's just a new wave. It's just a new generation and how things are being built and being created. So
Is Weaviate a system of record too? Would you use it as a primary data store? Like it has transactional semantics, or
no, it does not have transactions, but people absolutely use it as a primary data store. So if you work with a search, and it depends on what kind of architecture you choose, right? So, and we're still
like we would never say Elastic is a primary data store, right? It's like you keep your data in either a relational database or MongoDB or something, and then you do a secondary index for searching in Elastic.
yeah, sure you could do that too. But in the end, so the way that the information is stored or the data is stored in Weaviate and the indices are built, you can absolutely do it. What can you not do, right? If you're like a bank and you want to keep it as a system of record for banking needs, then you should not use Weaviate for that.
It's not that, okay.
The same thing is that we have like you can make graph connections in Weaviate. It's not a graph database, right? It's just for ease of use. But a lot of people use it as system of record, right? So you don't have to, but you can. The point that I want to make is like to stick to the developer experience part of it. It's how people use it. So, for example, if you talk about something, but nowadays the RAG thing, right? So with Weaviate, that just comes all out of the box. There's just not a lot of stuff that you need to add or that you need to do. It just comes out of the box. But even when it comes to from an operational perspective, for example, we pride ourselves with the multi-tenancy features that we have. All these indices that you can build and that you now can offload between memory and disk and very soon to storage buckets. That it becomes pretty sophisticated, if I may say so, in how that's all handled and processed and done, because the embedding is a first-class citizen, and the developer all finds that back in the ease of use of the client, right, or the driver, if you will.
Yeah, I never worked with a database that had like multi-tenancy as a first-class idea. It was always something you would think about.
Yeah.
Just one other variable that I filtered on tenant ID equals such and such. But we worked on this at DynamoDB because people were building SaaS applications on top of DynamoDB. Those SaaS applications themselves were multi-tenant.
Yeah.
And they wanted to be able to treat, okay, maybe one of my tenants is Google, a massive company, and one of my tenants is a little mom and pop shop, and I want to be able to treat their data differently.
Yes.
And, the database didn't sort of natively support that concept.
Exactly. And so how do we know this? Why do we do that in Weaviate, where we just, having beers on a Friday afternoon, making up that this is something? No, the open source community. People were like, hey, actually, we want to store vectors like this, or we want to organize them like that, or that kind of stuff. And we were like, because storing vector embeddings is expensive. It turned out that multi-tenancy is great for, we even have customers that have paid products and free tier products.
Yeah, right. That's the other thing.
Where they say like, okay, we want to have the customer, like their customers that they have in Weaviate, they can just go into the flat index. So it takes a little bit longer to retrieve, but that's all on disk, so it's cheaper. But like the moment they turn into a customer, we want it to go to memory, but if they're not using it for a couple of hours, it should be offloaded again. All that kind of stuff. And that's all in the database. So it's also just significantly cheaper to run it on scale, right? So and this is, now we're back from the developer experience more in the operational side of things. But all these kind of things come out of building AI native. And the thing that I'm so excited about is like that's with these generative feedback loops. And next week here in San Francisco, it's the Gen AI Summit, and I'm going to demo this on the big screen. What we're now doing in Weaviate, what we're working towards, that if you create a collection, you give it an instruction in the collection creation. So for example, you create a collection and you call it products, and then you say like, every description should be in English. And you start to just add data to the database as you've always been doing that before. But there's a generative model next to it that just has a scheduler and it just goes through all your data. And then if the data that you store does not adhere to what's in the instruction, it just updates it for you, right? And so this going back to that term of weaving an AI native, right? The model and database together being AI native. The way that people use our database and work with it is so different than traditional databases. It's just so different. So that's why I'm so happy that so many people support vector embeddings, because that shows that the market wants it.
Yeah.
And now we need to lead the way to the next step. There's like it's not SQL, it's not NoSQL, it's AI native. And so it's like this always, I love when you see these aha moments on stage. So for example, the first example that we had with this is actually on our website, is with Airbnb data. So the instruction that we give is basically in the data set, like every listing should have a valid description. So if you now add data just without a description, it takes the information that it has, generates a description, stores that into the description property in the document, right, in the object, and it does that for you. The saying I always have is like, we have this famous saying. I'm not sure if I'm allowed to curse on the podcast.
Go ahead, absolutely.
Shit in, shit out.
Yeah.
And I said like, this is the first time with AI native databases that we can turn chicken shit into chicken salad. That's new, right? That is really new. And in Weaviate, you do it like in a handful of lines of code.
Or you could tell it to generate translations. Like someone puts the description of the property in English, but we want to have a description of the property in Spanish and French and German.
Yeah, and building on that. So now I yesterday had a conversation with somebody about e-commerce. And what they're thinking about is that they're saying, well, we can now do real-time personalization. So let's say that somebody always buys yoga stuff, right? So apparently this person is interested in yoga. So then basically what you can give as an instruction is like, okay, generate a description for this user based on previous buyer behavior. So then if somebody searches for socks, you can generate an image of the socks by giving it the image as just as a basic 64 rendering of the image. And the text, hey, these are the yoga products that this person bought. So then if somebody goes to that page, they see the socks, but they might be on a yoga mat or something, right? That kind of stuff, that's not science fiction, that's real right now. And in the AI native database with Weaviate, you do that in a handful lines of code. That's different, right? So that's what I mean. That's an example of all these kind of differences. And we can keep going like with many of these kind of ideas. And that's what we want to power.
Well, so I understand that in the e-commerce use case. What's an example that might apply in like the financial world? You have a good...
Yeah, sure. let's say that in your banking app, you might have certain labels you've created yourself. So how you want to organize your financial spending. So now basically you can give it the instruction every time a new transaction comes in, label it based on these labels that the user has created, right? And then the model tries to do that, and the model says, I don't
So
have...
you're sort of using the vector database to do classification.
Yeah, sure. Yeah. It's anything you can express in an instruction. So, and I think, and now the big difference sits in the fact that the classification, that is not a similarity search type classification, but that is a GenAI type classification. That's very different.
What do you mean?
Yeah, so the example how I often explain the difference between something being or not being AI native is that I always say, like, so if I rip out the AI thing in the app, does the app still work? So an example, I always give the example of like a customer service tool, right? So one thing that you could do is that if you say, okay, I want to add labels to if a question comes in, I want to add labels to it, and then maybe you have like similar answers.
Maybe I've answered this before.
Yeah. So the non-AI native way of doing that is like question comes in, you vectorize it, attach like a bunch of labels based on that. They say, okay, what are the most common answers to this label? And you add it to the as an answer, right? That if you then take out the AI element, then just that automatic answering doesn't work anymore, right? So, but it's like the service still works. The AI native way of doing it is like you still vectorize it, you still store it, but now you tell a generative model search for relevant answers to the vector space by vectorizing, searching, and retrieving and determining if it's a good answer, and generate an answer based on that. And now you're not labeling it and having a couple of potential answers. You just have the model go back and forth between the database, search itself, generate an answer, and add that maybe as a threat to the interaction with the customer in the customer service system. That's very different. That's what I would call AI native. Because if you now take the AI out or the machine learning part, it just doesn't do anything. It doesn't work anymore. Your solution is broken.
So talking about LLMs in general, obviously ChatGPT was a seminal moment. I love it, and I use it all day, not all day. I use it every day for my work, different things. But I kind of go back and forth on whether it's actually going to still be, not ChatGPT, but LLMs. They have this problem of hallucination. Everybody knows that, they've seen it. And so people try to solve that hallucination problem. Maybe they do retrieval augmented generation and they feed in things that are more relevant to try to cut down on the number of hallucinations, or they do fine tuning and they try to use that to cut down on the number of hallucinations, but they can't ever get rid of it. And so I'm wondering if that's a fatal flaw in the whole idea of LLMs that will make it so that 10 years from now, we just give up and say, we never found a way to totally get rid of hallucinations. And this is like in my mind because all last night, all my social media feed, my friends that are in Discord, I'm in like a group chat in Discord, was just nothing but funny things that people found searching in Google with Google's new AI assistant box that comes back. I'm sure you've seen some of them too, but like asking Google, how many rocks should I eat every day? And Google says you should eat a few rocks every day because they're a good source of minerals. Or some that are just really, obviously that's a bad answer and bad, or posting a picture of a poisonous mushroom and it identifies it as an edible, button mushroom. And someone says, if you ate this, well, when they do your autopsy, your liver would be liquefied. Like, like really funny stuff. Or like, has the United States ever had a Muslim president? And it says, Barack Obama was the first Muslim president. And this is like Google posting these answers, right? Really things that could be kind of dangerous in certain ways. So, certainly, like misidentifying a mushroom would be very dangerous.
Yeah.
And some are just funny. It was like, how do I cure a kidney stone? And Google said, well, you need to make sure you drink 2 pints of urine every day. It's like, that's not right. Those are funny, and we joke about them, but I'm just wondering, like, are we ever going to solve this problem? And if not, does that mean they're just going to go away?
Yeah, so, what makes this one difficult, what makes the question difficult, is that what we mean with hallucination, right, in the context of the LLM, is the prediction of a token goes off the rails and then keeps predicting other stuff, right? So in the old models, one of the things that you saw is that at some point it started to repeat itself, right? And there was like this eerie thing that was like, oh, this is kind of weird, right? So the language that it now generates is like it's a coherent sentence, right? So the information that's being shared is incorrect.
Yeah, the structure of the sentence is right.
Yeah. I think with all the examples that you just gave, we can, based on our intuition, we can kind of understand where it's coming from, right? So I remember that one of the examples that I saw that had to do with like pizza and glue or something, that you could glue something. If it was like non-toxic glue, you could glue, stuff to your pizza or something.
Okay.
There was an answer. And then somebody traced that back actually to a Reddit answer somewhere where that was obviously in the context. That was like it was a joke.
Yeah.
Right. But it's like and it was interpreted. And that goes for a lot of these kind of solutions. I'm really not too concerned that will be solved. Right. So
You think it for sure will be solved?
yes, because all the examples that you give in the Google example is like just RAG at scale, right? And then we're now dealing with the complexities that the information is incorrect, or like that this in this case was like humorous.
But how is Google supposed to know whether it's correct or incorrect? I guess is the question. Because like let's say in that question about Obama, they linked to the the page that they got the answer from, and it was an Oxford academic page, but it was a book. It was the chapter title of a book. As I dove into this because I was curious what happened. And there's a chapter title of the book, and the title of the chapter was because it was really interesting. So like, how did this happen? I was like, is this real, or is this someone just like making up a screenshot and like causing problems? But it was like a legitimate AI researcher who posted it. It was a chapter of a title. This is Oxford Academic Press. Barack Hussein Obama, America's first Muslim president, ? It's actually a question mark. And so Google read it and said, oh, he must be. They missed the question mark. Right?
Sure.
But there's a lot of lies on the internet.
So then the interesting question becomes like, did the model hallucinate, or was it fed misinformation to get to this answer, right? So what I'm trying to get to here is like, we have hallucination in the form that it predicts a token after token after token, where the model was incorrect, right? So that it just goes off the rails, right? Or it has incorrect information on which it's basing the answer. So the example that you gave, so probably somebody said like, well, they might be using some kind of like Google's ranking system to say Oxford Press is
It's like a trusted source.
Is a trusted source. Maybe in the data cleaning they cut off, and I make this up on the spot, but maybe on the data cleaning they cut off certain.
They might have cut off the question mark.
The question mark.
Yeah, exactly.
So in that case, the model actually, from a purely technical perspective, the model presented the right answer. It was just the information that was fed was incorrect, right? So that will be solved.
But solved how?
Well, just by, you remember like in the early days of Google search, right? That I remember that one trick in the book was that you took a page, and then in the same color as the background of the page.
Use the same token over and over again.
Yeah, that you use the same token and then you scored higher.
Yeah.
So that was solved, right? So this kind of stuff, it's a data management problem, right? How the models deal with that information. I just cannot see how it will not be solved, right? So that goes back to our earlier conversation of how you can think about certain things, and then yes, there are some gaps here in our thing, like how it will be. But I would be highly surprised if it doesn't get solved. The thing with Google is like it's just immediately at this huge scale, right? And what's actually funny is the feedback loop that emerges, and I love that actually that humor is being used to create it, right?
Yeah.
I mean, when was the last time that we seen a product innovation in the front end of Google search? A long time ago, which I understand because it's the cash cow. You don't want to kill the cash cow. But now with everything that's happening, all of a sudden that front end is changing, right?
Yeah, it's a big change.
It's a big change, but they have to. And now with that feedback, oh boy, they're gonna do anything they can to make it better, right? Yeah. That's fantastic to live through that and to work on that. So I really believe that we are past the point of good enough in the models themselves. And these kind of things will be resolved with how the information is fed to the model. And these issues will emerge, will keep emerging, but they also will be resolved till we get to a point where we go like, okay, it's like what I meant, like with the example with SEO, right? So it's like it's very similar. It's just a different way how you present information to the systems. So if you go back, for example, to a model like it's still on Hugging Face, like Gödel, that was like before GPT, right? You could also do RAG with that, but it was just shit just came out, right? It was not hard. It was hard to read. You couldn't make sense of it. It repeated itself. That was really like a flaw in the model, right? So where you're like, okay, the model is just not good enough, but you could see a glimpse of it. And it was only with GPT 2.5 that we were like, or GPT 2, I should say, like, it was, oh, wait a second, we now past this point, now we see it. Or that we now feel comfortable it's going to happen, right? And yes, it was still screwing up things with math. It was still sometimes hallucinating. So, for example, in GPT-2, if you ask it for example, I tried it, of course, if I asked it who I am, then it generated something about a Dutch tech startup. And it's true that I'm Dutch. It's true that I work in tech, but the name of the company, it was like completely unrelated to me. And the funny thing was, and then it went on saying like, and Bob started this company with his brother. The funny thing was, I do have a brother, but I never started a company with my brother. But that other company that it mentioned, which is also a Dutch tech company, that founder actually indeed started it with his brother. So my point is, you were looking at that and you're like, that is incorrect. But we can see that this will be solved. And then we got like the newer versions of the models, and then those kind of problems were resolved. So long story short, I think I just don't see that. I mean, it's a challenge, but it's not a problem anymore. This will be resolved, right? And
see, I worry about this. I don't know if this is a real term, but I think about it as like LLM rot. So these models are trained on the corpus of, whatever's out there on the internet. And yeah, you could pay a farm of people to go generate misinformation, and people did, right? Like, go write these blog posts that have these mistruths because I'm going to try to sway public opinion on some topic that's important to me.
Yeah.
But it was somewhat limited because you had to pay people to sit there and type this content and generate the misinformation. But now we just have generative AI that can generate an infinite amount of misinformation and pollute the internet with, it might be that 99.999% of what's on the internet is pure misinformation, AI generated. And then that gets used to train the next generation of LLMs. So how does that feedback?
But that always has been the case. I mean, I remember, so one of the unsung heroes in the whole AI space is the Common Crawl. I mean, it's a foundation, and I believe there work like 2 people or something. It's like very tiny. But back in the day when we were working with Glove, and then we trained on like the Wikipedia, so we had this idea like, yeah, let's take some of these WARC files and then just train on a bigger data set. Let's just see what happens, right? Again, I'm talking like literally like 9 years ago now or something, right? When we were like working at that late at night, at some point, we had like this drinking game where you had like, shots, right? And you took a WARC file from the Common Crawl.
Yeah.
And then you just typed in a random line in that file. And if the content was not in some way or so if the content was in one shape or form pornographic, then you had to drink the shot.
Oh, no.
You were drunk in a heartbeat because the amount of crap that those crawlers are is insane.
Yeah.
So you are describing a dystopian state of 99% of the web being crap. I think 99% of the web already is like a lot of crap, right? So it's like it's actually the great work that the people are doing to try to figure out, like filter out, like what's actually good information, what's bad information.
Okay, but what if OpenAI is able, just yesterday they inked a deal with News Corp to license News Corp's information, so they can use, Wall Street Journal and whatever, Dow Jones, and like these news sources that News Corp owns. But News Corp is one news company. They're biased. All news sources have a bias, right? They're biased in one direction. But say the New York Times won't license their stuff to OpenAI. So does OpenAI become inherently biased because they're only able to license and use certain information?
Yeah, so I think that what happened with the GPT models, that introduced a flaw in the thinking. So if I may slightly alter the direction of the conversation to make another point that comes back to what you're asking, is that what happened with GPT was that there were 2 camps, right? Camp number 1 was, we just need to train it on more data, and camp 2 was, nah, that will not work. And camp 1 clearly won, right? So it's like, hey, so especially also with companies like OpenAI, it's like, if you give me $1 billion, I'll train on a huge corpus and it will be better. And if you give me $10 billion, I just train on a larger corpus and it will even be better. Well, you see the pattern that's starting to emerge, right? And then you give me 50 billion, and so on and so forth.
But they haven't found the point of diminishing return yet.
No, not yet. But, depends how you look at it. Because if you look, for example, going from the first GPT, the models, so that Gödel model, for example, from Microsoft, to the first GPT model, that was like so much better. And then going from 1 to 2 was already so much better, but not the same delta. Going from 2 to 3 so much better, not the same delta. So it's like it's already starting to slowly curve up. And so there's like a lot of people now that also are starting to ask.
So like you don't think GPT-4 is 10 times better than GPT-3, or?
Yes. And so what people are already doing is asking themselves the question, like, do we need to take a step back, rethink how we use language in these models? And there are even people now trying to make them completely absent of knowledge, right? So that there's language understanding in relation to language, but with the least amount of knowledge as possible, right? So that you have an external knowledge source. I believe that the original RAG paper actually, that's what they described, right? So how can we create a model that is, they use 2 models and they what they're basically saying, like, so one is used for encoding, and then on retrieval we use the other one to generate tokens. And the concept basically is like, can we have the knowledge outside of the models? And so that you go to smaller models with a very, very, very basic world understanding, who rely on external sources to predict new tokens.
So the training the models is a lot cheaper because they're so much smaller but hyper specialized.
Yeah. And then you want to have accuracy based on so you cannot use that model without an external data source. It's completely useless.
Because you have to feed in context in the context window to make it useful.
Exactly. And that is something that I'm very bullish on, right? And these models will probably be significantly smaller. The point I'm trying to make with this is that I'm just not convinced that training on even more data, trying to get to even more data sources, is gonna resolve that issue. I think it's way more gonna be more in sophistication in how these models are being trained. And I mean, luckily, like, because that kind of goes out of my realm of expertise, of course, but because we sit in that storage and retrieval layer. But the point I'm trying to make is that that if I had to make a bold prediction, like a year from now, we're not going to have bigger models. We're going to have smaller models that rely on external retrieval.
Okay. Yeah, that makes sense. It makes sense. Because you can only get so far by having one model that has everything.
Yeah, exactly. And so the question is, do you want to capture the knowledge in the model? So all the problems that you were just describing, which are very funny things, there was not a problem in the language understanding or the coherency of language generation from the model. It was in the knowledge that sat in the model.
Right. And using a corpus that had things that were untrue or misinformation.
Exactly. So if you then use retrieval, you can just say, like, you must base the results you're going to produce on the following information that I'm going to give you. Then you, as an end user, present it with information that is correct, right? So that's very different. And the problem that Google needs to deal with is that the use case that they have is the web. That's the Google use case. The Google use case.
Indexing all human knowledge, yeah.
And so the point that I'm trying to get across is, like, I've seen these examples too, and I thought they were funny too. But the problem is not the model not hallucinating and generating coherent results. The problem was the input data where the knowledge comes from is wrong. But we could have imagined that if...
But do you have to have a human sit there and classify each thing as, like, that's true, that's not true, that's misinformation, that's bias, that's... Like, how do you solve that problem at scale? I mean...
Yeah, okay, but...
That's a very hard problem.
That's a very hard problem, because then we go into the realm of what's true and what's not.
Exactly.
And
now you're back into the philosophers.
Yes, and I love to talk about that. The risk you run with it, you find yourself in a political discussion, right, or a moral discussion. But the point that I'm trying to make is, if we try to abstract that away, we can just say that the models, assuming that the information that we're giving it is, like, a priori true, it does a pretty good job of rendering something, right? And sometimes it still hallucinates, where it just does wrong token prediction.
Yeah. But you think that will be solved?
Yeah, by abstracting it from the knowledge it has. So let me give you an interesting example where that still goes wrong in older models. So let's say that you want to do RAG, and one of the data objects you have in your database is something extraordinary happened. There's like this. People have been able to transport the Eiffel Tower from Paris to Berlin. So now the Eiffel Tower is in Berlin. With the older models, so for example, GPT 2.5, if you, GPT 2, that's open source available. If you do RAG with that older model, then a conflict starts to emerge in what it renders, because you give it as, the question might be, what significant event or significant thing happened with the Eiffel Tower? From your database, it will retrieve that right information, right? So now you have that little article that says, like, the Eiffel Tower is like, what an exciting thing, they moved it from Paris to Berlin. The model will have a little bit of a conflict because of the knowledge that it has in the model, because it has so much data that the Eiffel Tower really is in Paris, right? That it might result things like, well, the Eiffel Tower was moved to Berlin, but it's probably not true because it's really in Paris and that kind of stuff. It might render something like
conflicted,
that.
yeah.
It's conflicted. So that's an example where we just want to actually remove that information from that knowledge from the model, and that it's actually better to have less information and knowledge in the model, but just the language understanding, right? That it understands that there's a. So those kind of things are more tricky, and it's interesting to see that in these RAG pipelines. But I really believe that an external data source plus a smaller model with language understanding and less knowledge, so that we do not rely on the knowledge in the model, but in whatever we give it from an external source, that's the future, I think.
How far away do you think we are from being able to legitimately program in human language? Like we were talking about that earlier. Because I'm doing it now. I'm using a cursor.sh, which is a VS Code fork. I write a sentence or a paragraph of what I want it to code, and it goes off and generates the code for it. And I do it in human language. And then I change it in human code, in human language. And so I don't have to write the code if I don't want to. But I can't tell it to just make a whole distributed system and have it go do it. But like, I got to imagine we're getting there at some point where a product manager can just say, this is my product, and it will build it. But is that 3 years, 5 years, 20 years? Like, what do you think? What's your guess?
I think that will never work. And let me explain why.
Still got to write computer code.
You still need to write computer code. Might we see a new language, programming language in the future based on LLMs? Maybe. Let me explain why. One of the big problems that we have in language, so now we're back onto the language philosophy kind of game, but the thing is, like, the problem that we have in language is like, so if you tell me something, or if I tell you something, you have your context, I have my context. Right?
We filter it through our own.
We filter it, yeah. And then we express that in language, which is very unfortunate, because we lose all that context and in when we're talking to each other, right? And experiences that we had and that kind of stuff. So let's say you have a website, right? And it's the most simple website that you can think of, because it's just a landing page and it just has an
hello world.
It literally has, that's it. It's a landing page with hello world. And so the product manager goes like, I need a website that just is that says hello world as a placeholder in big red letters. So what's big and what's red? And what kind of font are these letters, right? Do we mean with big H1? Do we just want to set like a big number? What do we mean with red? Do we mean like the system default for red? Or do we have a certain tint of red because it turns out that this person is working for, I don't know, for a company where there's red in the logo? And so on and so forth. So what starts to happen?
But it became an iterative thing. Oh, make it bigger. Make it a darker shade of red. Like you get, but you can do that in human language.
When we do that, what starts to happen? Which starts to formalize it. So we say things as like, make it 5 pixels bigger, 2 shades of red darker. So what you start to see is what slowly starts to emerge is a formal language. What's a programming language? A programming language is a formal language to express something. So, and now you tell the model, do that again. We have it twice. That's a function.
Yeah, loop or
loop.
Yeah.
So keep doing that again. Right? So before you know it, the language so what I find fascinating, that is like the work that's happening, that's coming out of Stanford. It's called DSPy, and we spend a lot of time and effort on it. And it's a way of programming the prompt, right?
Yeah. Prompt engineering.
Yeah. No, not prompt engineering. It's a new iteration after prompt engineering, where you give certain programming like instructions to DSPy, and it just optimizes the prompt for you. It formalizes the prompt. So the point that we're trying to make is that if we program something, before you know it, we start to introduce formal concepts to agree on what we want the system to do. So every time that we introduce something that is subjective, we're dealing with the problem. What does that mean? So if you say, okay, so back to that example, hello world in big red letters, right? So then the subjectiveness sits in big and in red. Then you could say a little bit bigger, then the subjectiveness sits in little bit. Is it a pixel? Is it 10 pixels?
But I think that's okay. I mean, this is how product managers iteratively refine a product. Is like, they don't think about the code that needs to be written. They think about the functional requirements, and I want it bigger, I want it more red.
Yeah, what I think that will start to happen is that people will say that you then tell the model, if I say a little bit, it's like the previous thing you've done. But if I say a bit, it's like twice the previous thing you've done. And before you know it, you start to introduce like formal concepts to describe it. And it looks more than like human language, but it's so very similar, like how Python or Ruby is a little bit more intuitive than C, right? And how C is more intuitive than assembly. So that's what I meant. Might we see a new formal language that is even less,
something higher level,
an even higher level? Yes, but I do believe that to interact with the machines, we need to give it some form of context, and we do that in a formal way, which then turns into a programming language. So might the paradigm shift completely? Sure, maybe. What we might see earlier is like reverse engineered stuff, right? Create me a hello world landing page like that page.
Yeah. Something similar.
Yeah, something similar. I think that is something we will see sooner.
It's just easier to copycat something, I mean.
Yeah.
Or make a derivative of it.
Yeah. Because if we interact with the machines, we need to provide a context. And how do we do that? We formalize it. We even do that as humans. We just had a very long discussion because we had different contexts around the term hallucination.
Yeah, sure.
I was thinking about like the term hallucination is like the token predicted after the other token is wrong and therefore it goes off the rails. And you use it let's see if I have your context correct now.
Yeah, you use misinformation.
Misinformation. Yeah. So if before we would have started this podcast, like, okay, let's make sure we have our nomenclature straight.
Yeah, what does hallucination mean? Yeah.
Yes, exactly, and so on and so forth, right? And how we formalize it.
Yeah.
And then before you know it, it looks a lot like a programming language.
Yeah, it does. All right, in the last minute here, people who want to get into the AI space, it's a hot space. Quick advice. What advice would you give to someone who says, I want to get in the AI space? What should I be thinking about? Where should I go?
So start now. Don't wait. Just start. Build something. And then the question is like, okay, build something, yeah, but what? Try to find a use case, right? And it doesn't have to be a complex use case. It can be super simple. It could be something that you do for instance, so if you're an accountant, you might say, hey, I always see that I do this repetitive thing in Excel. Well, it's super easy to connect, and nowadays to connect the model to Excel. Try to automate that. That's a beautiful use case. Use the beauty of open source, make it publicly available, see if people like it, and so on and so forth. But start now, and I'm a big believer in build it yourself. So if you need to learn a couple of things, just take the time to learn it and to build it, because the time of making and building is now, right? And who knows how long that window of opportunity will still stay open? Probably for a long time, like the window to create websites, the window to create apps is also still open if you have a unique ID. But now the low-hanging fruit ideas can now be created, right? And that's super exciting. So it's such an exciting time.
And it's changing so fast.
And so do it now. Start building, So when you're done listening to this podcast, open up your laptop and go.
Go download Weaviate.
Yes,
and
sure.
build your app on Weaviate.
Exactly.
Absolutely. All right. Thanks for coming today, Bob. I know you got to go catch a flight, but this has been a wonderful 2 hours.
This was fantastic. Thank you so much. I really enjoyed this conversation, so thanks for having me.